हॅलो, देशमुख सर.
फोन लावा सर, त्याला फोन
हॅलो.
फोन लावा.
बर, लावतो. सर, गुड इव्हनिंग.
गुड इव्हनिंग सर.
हॅलो, देशमुख सर.
चव्हाण सर, त्यांना प्रॉब्लेम असेल जॉईनिंगला तर सुरू करा तुम्ही. चव्हाण सर. हॅलो.
हॅलो, परतुल सर. हॅलो.
Yes, sir.
ओके.
Sir, I think we should start. Let's
Yeah,
not
okay.
wait for anyone.
Okay, sir. Okay. Good evening. Good evening.
Yeah,
Yes,
good
sir.
evening
Good evening.
everybody.
Okay. I welcome to all dignitaries and participant to the fourth lecture in the national level lecture series on mathematics. We have called distinguished academician for this lecture series. For today's lecture, we have the eminent personality in mathematics, Mr. Partul Gadakkar sir, Assistant Professor, Departments of Mathematics, Modern College, Shivajinagar, Pune. Sir has set JRF in 2003, GATE in 2004, All India rank 16, set in 2005. I am well assured that Pratul sir lecture will be path-breaking for students and teachers. You will definitely enjoy this lecture, and the chairperson of this session, well-known academician, Professor Dr. S.M. Jogdan sir, Senate member, Swami Ramanand Tirth, Marathwada University, Nanded, Professor and Head, Departments of Mathematics, SSGM College, Loha, also deserve a words of thanks for his motivating presence. Thank you very much, sir. Now I request to Dr. Jogdan sir, please start the session.
Okay, good evening to everybody. Dear participants, on the occasion of Azadi Ka Amrit Mahotsav, Department of Mathematics, Digambar Hindu Mahavidyalaya, Bhokar organized a national level lecturer series. Today is the 4th day of this national series lecturer. Today we have with Professor Gadi Atul sir. Yes. Praful Gadagkar sir, which will be eminent person in Pune University. Just Mr. Chauhan sir introduced him. He will deliver a lecture on topology. It will be very helpful to all participants, teachers, and students. So I will request Professor Praful sir to continue. He is a lecturer. After a lecturer, we have some discussion on this topic. So all participants are requested to discuss if you have any problem. So I request Mr. Praful sir to continue and start your session. Thank you.
Okay, thank you, sir. I first of all take this opportunity to thank IQAC and YCMOU of ACS College. Special thanks to some of the people who have taken efforts behind organizing this workshop. Dr. S.B. Chavan, Dr. A.B. Chavan, Dr. Take, Dr. Hoge, Rahul Deshmukh sir, and obviously my chairperson Jogdan sir. Thank you for giving me this opportunity to deliver a lecture in this national lecture series on maths. So I wish to now start my presentation. I will share my screen. It's not a PPT file. PPT files are usually boring. So I will use my notepad and I will start the presentation. I will switch off my camera so that it will not distract you people. I also request other participants to switch off the cameras because it is quite distracting for the participants. So let's follow some simple ethics and move ahead. Somebody just tell me, can you see the screen? Sir, is the screen visible? Chavan sir?
It's visible, sir.
Yeah, okay. So the topic given to me is topology. Don't go on my handwriting because this pen tablet, you know, is really a bit uncomfortable for us, but I'll try to keep up a little bit of good handwriting. So what we do, basically, what thing comes in to mind when we understand, when we want to learn topology. So I will take a set X, and this set X has subsets. These are the subsets of that set X. So I'm taking a set X. Obviously, I will take a set X, which is a non-empty set. There's no point in taking an empty set. And I will start collecting subsets of that set. I'll start taking subsets. Now in this set, you obviously have one set, which is an empty set. So I will put empty set in my collection. I will also take X is also a subset of X. Every set is a subset of itself. So I will take X also. And I will start inserting subsets of that X in this collection. Okay, and this set of collection, I'm going to denote it by tau. Okay, so this tau will be set to be a topology. Now, when is tau set to be a topology? It should satisfy some simple things. First of all, empty set must be there in that collection. That's why I've taken this empty set. Second thing is that the complete set also must be in your collection. So this is our collection, okay? So I'm taking a set, I'll just go back. I'm taking a set, I have subsets. I have inserted some subsets inside this collection. In that collection, I have purposely taken empty set. I have taken the full set also. And this collection will be called as a topology. When I'm going to call this collection as a topology, I'm going to call this collection as a topology if empty set is there and the full set is also there. Second is that if I take union of these subsets, if I take union of these subsets, that union should also be in the collection. That union is also must be a part of this collection. For example, if I'm having A inside the set, if I'm having A inside the collection, I'm having B inside the collection, then I will search, is A union B written in the collection? Is B union C written in the collection? Is A union C written in the collection? So unions of subsets, unions of elements in this collection should also be inside there. It should not happen that A is inside the set, A is inside the collection, B is inside the collection, but A union B is not found in the collection. In that case, this will be a problematic. So what we want for a topology is that A union B also must be a part of this collection. Not only that, which type of union? Now there are two types of union, either a finite union or an infinite or an arbitrary union. So here I want arbitrary union must be a part of this collection. Arbitrary union means you take finite, infinite, countable, uncountable, any type of collection. And third thing is intersection of these sets. If I take intersection of the subsets, that intersection must also be a part of this collection. Means if I have B inside the collection, I have C inside the collection. In this list of, in this elements of collection, somewhere B intersection C also must be a part. Somewhere A intersection C also must be a part, and so on. Which type of intersection? Now here I want only finite intersection of subsets must be also a part of this collection. If all these three properties are satisfied, first is that empty set must be a part of the topology, X, the full set must be a part of the topology, and arbitrary union of open sets is also, arbitrary union of these sets is also inside the in the set, in the collection, and finite intersection of these subsets is also a part of this collection. Then I will say that tau is a topology on X. Tau is a topology on X. Here I understand that there are students from graduation also, post-graduation also. Okay, so for this is basically for post-graduation students, but for students who are in graduation, जे students graduation मध्ये आहेत, they are studying a very elementary course related to topology. That course is called as metric spaces. So, this topological spaces are a higher version or a generalized version of the topology of metric spaces. Okay. Now, what is an example? Usually one understands when you give one example. So I'll take a set X and I will take three elements, suppose ABC. This is a very, very standard example for teaching topology course. Okay, I will take a collection now. I'm going to call that collection C, and I'm going to take, I'm going to draw this figure. Let me show you the diagram. It will be clear to you. I'm calling the three sets ABC. Then I'm collecting first set is A. First subset is A. The second subset I'm taking is AB, both AB, because this is also a subset of the set. And then we know that a topology must have empty set also inside it. And the topology must have The full set also, the full set is ABC. So this collection C is what? Is a topology on X. Is a topology on X. If you take union of this set and this set, the union of the set A and AB is AB. So this is a part of this collection. See, here it is there. If you take intersection of these sets, the intersection is what? The intersection is singleton E. Is it a part of my collection? Yes. You see, both the definitions are, all the three things are satisfied. Empty set is also there. Full set is also there. Union I have taken, that is also in the collection. Finite intersections I have taken, that is also in the collection. So this is the simplest type of topology that you can think of on a set X. Let me have a word with my participants. Am I audible? Is everything going clear? Can you just, some people raise your hands or put a thumb if you have, so that I'll understand that I'm going fine. Okay, good. Thank you. Thank you. Enough. Now when you're studying linear algebra, if you remember your linear algebra course, you study vector spaces, correct? When you study vector space, what is the most important concept in the vector space? Can you just put it in the chat box quickly, that one word? What is the most important word which is coming in the study of vector spaces? Come on, type any one important word that you, basis, correct? Basis is very important in a vector space. You have a basis, because basis is actually what? So suppose this is my R3. Okay, so I'll talk a little bit in Marathi also, because some participants are requesting me to talk in Hindi or Marathi. I'm comfortable with Marathi, not with Hindi. So so this is your R3 space. Here apla R3 ahe. And you have the basis as I'm going to call E1, E2, E3. I will call them B1, B2, B3 instead of calling E1, E2, E3. So basis vectors are B1, B2, and B3. What are B1, B2, B3? These are actually parents of this vectors of this space, right? Because they will generate the entire space. The span of these bases is the complete R3, correct? So similarly, like vector spaces, we are now searching for a basis in a topological space. So we have a basis in a topological space also. Okay, now that basis of topological space, I will show you one. I will just stop the screen share and open it again. I will show you one small animation sort of thing, and then we will see what is the basis. Okay, somebody please just tell me when you see the screen of my animation, just put that yes, we can see the thing. I will just close the screen share and open the screen share. Just a minute. Yes, can you see something like this? Can you see this?
Yes, sir.
Okay, thank you. Thank you very much. So let us look at this now. Okay, now what we will do, I will just maximize this window. I will maximize, okay, for 1 minute. Okay, now this, imagine that this is your three-dimensional space. This is this sheet that you see, that visible nahi hoga, but ho jayega visible. So what I will do is I will draw some spheres. I'm in the three-dimensional space. I will draw some spheres here. Okay, can you see the sphere? Somebody can unmute and tell me quickly.
Yes, sir.
Thank you. So now we will draw some spheres here. Okay, you see they are intersecting to each other. and I will go on drawing spheres like this. ओके इसको मोशन करके भी देखते हैं, जरा हिला के देखते हैं. दिख रहा है सबको? Yes, can you see that? Right? So now tell me that if I go on drawing spheres like this, if I go on drawing the spheres like this, will it cover my entire space? Will it cover my entire room? If you are sitting in a room and if you are blowing balloons in a room, what will happen after some time? The room will be completely filled up by balloons. Correct? Now, let us go to the, mathematics people कैसे देखते हैं इसको? Mathematicians, this is okay, this is fine. But mathematician इसको ऐसे देखेगा. ऐसा देखना चाहेगा. This is what mathematician wants to do. Okay, so this is the picture behind this thing, right? Now I will do what? I will take two, I will just make a new file. यहाँ पे बहुत कचरा हो गया है. I'll take a new file. I will now draw two decent spheres. Okay, they are intersecting each other, right? And I will go inside the two decent spheres, intersection of, look at the two decent spheres like this. They're intersecting each other. I'll zoom it a little bit. Now tell me, look at this intersection. This intersection area is this much, right? Can we draw a sphere inside this region? Can you put it in the chat box? Yes, can you draw a sphere, a small sphere which is sitting inside this intersection? Yes or no? What do you think? Yes, yes. So इसके अंदर हम एक स्फीयर निकाल सकते हैं, राइट? सो इसके अंदर एक छोटा सा स्फीयर निकाल देते हैं. ये देखो, राइट? ये भी निकाल दिया मैंने. छोटा सा स्फीयर है, वो छोटा स्फीयर भी मैं जूम करके देख रहा हूँ. So this sphere, this white color sphere is sitting inside what? Is sitting inside the intersection of the two spheres, correct? Let me put in the chat box. Let me put it in the chat box. Can you do this always? Can you say yes or no? Can you do this always? If I take any two intersection of spheres, can I always draw a sphere inside that intersection? Yes or no? कोणते पण दोन स्फिअर्स घ्या आणि त्यांना इंटरसेक्ट करा. त्याच्या आत आपल्याला छोटा स्फिअर काढता येईल का? Good. So people are saying yes. Good. Very good. Let me change it now. Okay. Let me change the picture. Now what I will do is, instead of taking a sphere, I will take box. I'll take two boxes. This is one box. This is another box. Okay. Are they intersecting to each other? I don't think they are intersecting to each other. Let me take a new box. Boxes. Here. Are they intersecting each other? Let's look quick carefully. Show हाँ होता ते ना intersect का नहीं होते लांब गेले. Okay. बॉक्स काढू आपण एक. हे दोघं होता ते का इंटरसेक्ट बघूया एकदा. हा होता ते. करेक्ट. मॅथमॅटिशियन याला कसं बघेल? असं जाऊन बघेल. बेटर आय सी इट लाईक दिस. ओके, हे दोन बॉक्सेस आहेत बघा. या बॉक्सेसच्या इंटरसेक्शनच्या आत मला छोटा बॉक्स काढता येतोय का? त्यांच्या आत एक छोटा बॉक्स काढता येतो का? 3 येतो. करेक्ट. 2 बॉक्सेस घ्या आणि 2 बॉक्सेसला इंटरसेक्ट करा. टेक 2 boxes and intersect those 2 boxes and try to see that can I draw a small box which is inside the intersection of the 2 boxes. I hope you can, all of you understand what is the intersection of the 2 boxes. Okay, can you do that? Now, is a yes or no? No, it's not Autodesk. It is 3ds Max. 3ds Max. I mean, yeah, you call it 3ds Max, right? So inside the intersection, you can also draw a box. So this gives us a motivation of our definition for the basis. So let me go back to the writing pad. Okay, so what is a basis? First of all, a basis B of a topology is the collection of some special objects. Now, what is the important property of that of that? If I take a B1 inside that basis, and if I take B2 inside that basis, and if I take the intersection of them, like I was having a sphere, and if I take a intersection of the two things, then inside that there must be another element of that type, right? I have taken a sphere, their intersection. Inside that intersection, you also got one different sphere, right? So this is first sphere, second sphere, and inside that intersection, I got a third smaller sphere. Okay, can you do that? We could do that, yes. And second thing is that I told you that if you take a room and if you start blowing balloons in a room, finally what will happen? The room will be filled up by the balloons, right? So if you take any point in the space, if X is any point in the space, okay, for example, I'm showing you this in the picture. This is my room. This is my room. And if I take any point in the space in my room, okay, then there will be some balloon which will cover that point. There will be some balloon which, because the room is filled with balloons. So every point in the space is inside some balloon, correct? So if X is in X, then there exists a basis element B such that X is contained in that basis element. Who is B here? So example of R3. So what is an immediate example? So an immediate example is that in R3, the set of all spheres forms a basis. Correct? Because if you take any two spheres, intersect them, there is a sphere sitting inside it. If you take any point in the room, that point will be contained in some sphere. So in that case, the set of all the spheres is called as what? It's called as basis of R3. Question, let me ask you a question. In R3, if I take the set of all boxes, is it a basis? Yes or no? Answer after my comment. Yes or no? सगळे बॉक्सेस घेतले तर तो बेसिस होईल का? चेक करा. 2 बॉक्सेस घ्या, 2 बॉक्सेसचे इंटरसेक्शन काढा. त्याच्या आत एक छोटा बॉक्स मिळेल का तुम्हाला? If you take any point in the space, can you find a box which is containing that point? No. Mohammed says no. Rahil, what is the problem? Why do you think it is no? Can you just unmute and tell me? Okay. Okay. No reply means you agree what I say. So the answer is yes. So it forms the set of all boxes also forms a basis. Now look at the set R2. Look at the topological space R2. Okay, can you think of something which will become a basis? Which type of objects should I put in my basis? Can you just tell me the basis of R2? I'm typing a comment. After that, please put your answers. Basis of R2. What do you think the basis of R2 is? What should I put here? Which type of set should I put here so that it will become basis? Now I have an idea of basis of R3 is containing spheres. So what do you think will basis of R2 work like? Durva, you have to be careful. You're typing circle. I see your answer, but you have to be a little bit careful. No, I'm not asking you the basis of a vector space. Sankit, this is a basis of vector space. I'm asking you the basis of a topological space. Yes, okay. Mansi is also typing circle. Okay, ठीक है. तुम्हाला जे वाटतं ते तुम्ही at least type करा. Square. हे बघा, तुम्हाला सगळ्यांना लोकांना एक लक्षात येते का? Do you people understand one thing, that there is a difference between this? So this is called circle. And what is this called? उसके अंदर का भी पार्ट चाहिए मुझको. सर्कल मतलब सिर्फ बाउंड्री हो जाएगा ना. Closed circle. No, Avinash, no. Here. Planes. Pradeep, planes are like this. These are planes. What is this called? Circle के अंदर का. Sphere. Komal, sphere is in 3D. We are in 2D. Come on. It's disk. Disk. No. That is equation of circle, Pratibha. Okay. Disks. So I will collect disks. I will take all disks क्योंकि अंदर का भी होना चाहिए ना. Okay, now imagine if you take two disks and if you intersect them. Okay. Can you find a disk which is inside this part? Can you draw a disk which is inside this? Yes or no? Y or N type करो. Can you draw a disk which is yes? इसके अंदर तो हम हमेशा एक डिस्क निकाल सकते, राइट? एक डिस्क इसके अंदर मिल गई. Correct? Yes. So I understand that. What is the basis of R2? The topological space. Okay. I'm talking about, this is not linear algebra lecture. कल linear algebra का lecture DD Pawar sir ने लिया है. Okay. उनका basis E1, E2 correct था. Okay. But your basis is what? The basis is a collection of all disks. Okay. Now, why do you think that if I go in R2 and if I draw circles, why circle is not a basis? Why circles is not a basis? क्या हो जाएगा? इसका problem क्या होगा? इसका problem ये हो जाएगा कि collection of circles जो है ना, वो तो topological space ही नहीं. If you take union of circles, अगर दो circles को जोड़ दो, तो क्या ये circle है? Is this a circle? There will be a problem in this, right? Every point must be contained. It contains only boundary points. Yes, right. So circles will not be a correct answer. So you have to be careful as a topology student. Now you have to be careful. What is a circle? Circle means something which is only having this part, right? X squared plus y squared equal to a square type, or x minus a whole square, y minus b. And disk is something which is containing everything inside it, right? So use these words very carefully. Okay. So this is B. Think of the real line. Let us go to the real line. You have now from understanding 3D is easy. Getting to 2D is little difficult. Getting to one-dimensional becomes more difficult. So what is the basis of this? Yes, Neha, don't worry. I will send you everything. Okay. It's on YouTube live. So you can always see these lectures. Yes. What is the basis of this topological space? Real numbers. Can you make a guess? Now what will happen? In R3, we had spheres. In R2, In R2, we have disks. In R, Durva is right, it is intervals. Okay, you take all open intervals. Very good, Pradeep. Okay, you take all open interval, collection of all open intervals. Right? For example, let me just quickly verify. If I take any point in real line, alpha, is this point in some interval? Yes. I can put it in the interval alpha minus epsilon to alpha plus epsilon. So any point is there. Secondly, if I take any two intervals, and if I take the intersection of the two intervals, A, B, and then I have an interval CD. Where is the intersection? The intersection is here. This is the intersection of the two intervals AB and CD. What is the intersection? The intersection is CB. Can you find the interval inside this interval CB? Can you find an interval which is sitting inside this interval? Yes, I can find a small interval sitting here. Say that interval is alpha beta, which is contained in what? Which is contained in the intersection. Correct? So this means that this really forms a basis for my real line. Okay. Now we are not happy with what is going with only one topological space, right? Whenever you learn something about real line, our habit is to try to extend the same idea to R cross R. So you go to R2, try to extend the idea to R cross R cross R. So this will be this is our habit, right? So if I have a topological space X, if X is a topological space, right? What I will do, I will take another topological space. Why is another topological space? See, whenever I say topological space, बऱ्याच लोकांच्या डोळ्यापुढे अंधार येतो. Don't do that. Just simply think of real line. Just simply think of what? Simply think of real line. Or think of R2, think of R3. All these are topological spaces. Okay, so the simplest thing is R. Take one topological space, take another topological space. The another topological space that I'm taking is also R. These are topological spaces. Or you take R2, no problem. Then I will say, if I have X as a topological space, Y is a topological space, then I will try to take the product of these topological spaces. In this example, what is the product of topological? What is R cross R2? It is R3. So that is also a topological space. Correct. But the topological space X has basis. 1 minute. I will just disable the annotations for my people. Okay. So if X has basis B1 and Y has a topology, Y is also topological space, has a basis B2, then I want to find the basis for the topological space X cross Y. What do you think I should write here? What do you think I should write here? Okay. So I know it is not easy to type in the chat box. So this basis 1, the basis of X, contains all elements which are of the type U, where U is an open set. I will call them U alpha. U alpha is our open set in the topological space X. B2 has a base, is a basis which is containing V alphas, which is U alpha. V alpha also are open sets in Y, and therefore now my basis for X cross Y will contain now, will it contain the unions of U alpha V alpha? Will it contain the intersections of U alpha V alpha or something else? Now you can put it in the chat box now. Okay. Others, can you give a try? Intersection, Ashwini. Ashwini, remember U alpha is in X, V alpha is in Y. They are in different sets. त्यांचे इंटरसेक्शन घेता येईल की नाही आपल्याला सांगता नाही येत ना. एखादा सेट जर तू आर मधला घेतला, आर मधला एखादा सेट घेतला आणि एक सेट R2 मधला घेतला, त्यांचे इंटरसेक्शन आपल्याला काढता येतं का? इंटरसेक्शन काढण्यासाठी दोघं सेट एकाच सेटचे मेंबर्स पाहिजे ना. राईट. येस मानसी. Yes, correct. So you have to take the Cartesian products because that is the most natural thing. So U alpha cross V alpha will obviously form the basis of what? Will obviously form the basis of the space X cross Y. Okay, because you have already taken the, here you have taken the Cartesian product. So basis kya hoga? Basis bhi to will come up from the Cartesian products itself, right? So remember, this is one of the important concept in topology that you have. It naturally comes because we have a habit of making products, right? When you learn your set theory, when you learn about set A, when you learn about set B, after that, you don't stop. You start taking unions, you start taking intersections. And the worst thing is that you go for the Cartesian product, okay? From where you start developing something called as functions and so on, so on, so on. This is how you study, correct? So when I have so I can create new topological spaces. If I have two topological spaces with me, what is the new topological space? The best thing is take the Cartesian product of the two topological spaces. Okay. Now in topology, there is some in like you have now whatever the members of topology are. So this is very important. Okay. All members of topology tau of a set X, Okay, what I mean to say, I will tell this in Marathi also so that you people will understand. X set घेतला आपण, right? Then I have taken what? I have taken subsets. I'm taking subsets. And this, and I'm not taking all subsets. I'm choosing some of them. त्यातले आपण choose करणार आहे. कोण empty set, phi, then U1, U2, U3. असे काही special elements आहे. They are satisfying what? हे subsets का घेतले? Because they are satisfying some special properties. Okay, that arbitrary union आहे and finite intersection आहे. असे सगळे लोक आपण गोळा केलेले आहेत. Okay, हे काय असेच randomly मी choose केलेले नाहीये. सगळ्यांनी लक्षात ठेवा. I am not chosen them randomly. They are satisfying the definition of topology. Okay, वरती जी definition दिली, right? And what I will do is I will now declare that if I pick up any member from this topology, that is what I'm saying, all members, okay, you are going to pick any member from that topology. We are going to say that that member is an open set. We declare they are open. What we declare? They are open sets. Example. What is an example? I take topological space R. R is a topological space. It is having tau as a topology. Okay, and I will now pick up what? I will pick up any set from that topology. Suppose the set is U alpha. This U alpha I am going to call what? This U alpha I am going to call open set. वो शायद open set जैसा दिखता भी ना हो. It may not look like because all of us have a mindset कि open set मतलब open interval. ऐसा नहीं होता. Okay, it's ऐसा कुछ नहीं है. वो open interval जैसे नहीं दिखता होगा शायद. वो कैसा भी दिखेगा. I don't know. But okay, Is there any problem? Screen is visible, right? Okay, yeah. So that set need not look like an open interval. It can be anything, but I'm going to call it what? I'm going to call it as open set. Once I have called something as an open set, means what is an open set in a topological space? Any member of that topological space is called as an open set. So the question comes that now who should be the closed set? Obviously, I'm going to say that A is a closed set if the complement of that set is open. This is one of the most simplest definition which you will see in topology, right? Then once you have a close, okay, let me go for an example. Okay, let me just stop screen sharing for 1 minute and get you back. Somebody please tell me if you can see the screen share when I start sharing it. Is it visible? Yes. Okay, good. Okay. I will go in I'm using GeoGebra. Now let us type here equation x greater than y. Typing x greater than y. दिख रहा है सबको क्या हो रहा है? ये पिक्चर किसका दिख रहा है? You see this purple region? Okay, this set that I've drawn, is it an open set or a closed set? Quickly type open, closed, O type karo, C type karo. Let me see how many of you people are understanding what is open set. Is this an open set in R2? Correct. Good. If I take x greater than or equal to y, you see now the boundary is also included. So now this set is a yes, this is a closed set. Okay, now new question. I'm typing the equation. The shaded region, is it open set or a closed set? Correct. Good. One more verification from my side. The green region, the green thing, the green object that you see, is it an open set or a closed set? Durva is saying it is not open, not closed. Okay. Now see, all of you pay attention. You can see my screen. Yes, it is a line. I know it's line, but is it open or closed, Mansi? Okay, अपन तैसा answer दिए. Okay. Now look at this. Y is equal to 2x plus 1. अभी y equal to 2x plus 1 होगा तो इसका complement लेते. What is the complement of y equal to 2x plus 1? मतलब y greater than 2x plus 1 होना चाहिए और दूसरा क्या होना चाहिए? Y less than 2x plus 1 होना चाहिए. Y is less than 2x plus 1. Right, and now remove this line. So this is the complement. Now you see this is a complement of that particular object. Correct. So now tell me, ये जो region है, is this open? Do you see that the left region is, see, left region is open. Okay, I have removed the right region. Now I will remove the left region and take the right region. Is this open? Yes. If you take the union, we know that union of open sets is also open. So y greater than 2x plus 1 and y less than 2x plus 1, both are open sets. The union is open. And therefore, their complement, which is this line, will automatically become what? The line will automatically become what? It will become a closed set. Okay. Should I repeat this argument? I want to check whether this line is open or closed. So what I did, I found out the complement of the line, this, and both are open. The union is open. Therefore, the complement of those regions is a line becomes automatically a closed set. Right? Let me get back to my writing page. So as soon as closed sets are understood, people start talking about closure. So what is a closure? You know, in topology, closure is thoda sa difficult define kiya hai, but it is okay. So what you do, I'll take the next page. So I will take a set, suppose this is X and this is a set A. Okay. What I will do is I will take, so the set A, I will take closed set which is containing A. So I'm taking a K which is containing A. I will take all closed sets which are containing A. So I'm taking all K alpha which are closed such that A is contained in the closed sets K alpha. Then I will define that the closure of A is the intersection of all these closed sets. Whatever is common in all the closed sets, whatever is common in all of them, that region I will shade. So I will start slowly, I will start shading. This is common, this is common, this is common. This is, whatever is common in all of them, that is called what? That is called the closure of the given set. Example, if I take set A, which is open interval 2, 3, what is A closure? Quickly type in the chat box. What is A closure? Yes. Do you guess what is the closure of A? Intersection K. No. The answer kitty hai? Closed interval. Yes. It's closed interval. It will become the closed interval. Correct. Similarly, when you take a set A, yes, correct. Good. Very good. If you take A, yes, very good. I'm taking A, and now I want to find the interior of A. I want to find what? I want to find interior of A. Now what I will do is, instead of going outside, I will go inside and I will take open sets which are inside the set A. So what are U alphas? U alphas are open sets, and all these U alphas are inside A. Okay. There are two types of students. काही स्टुडंट बाहेरून डोकं खातात, काही स्टुडंट आतून डोकं खातात, डोक्यात जातात काही मुलं. काही मुलं वर्गात जाऊन त्रास देतात, वर्गात बसवून त्रास देतात, ते बाहेरच आहेत. आणि काही मुलं येऊन तुम्हाला खूप वाईट प्रश्न विचारतात, ते आतून डोक्यात जातात. सो दीज आर लाईक interior points. These are interior students who are troubling you interior, and these students are your closure. Okay, so what is the interior of A? So interior of A is union of all these U alphas. That will be the interior of A. What is an example? Let me ask you one simple question. If I take A to be singleton 0, what do you think is the interior of A? What is the interior of A if the set is just a singleton set 0 in R? Am I audible? What do you think is the interior set? What is inside this set? Which open interval you can draw inside this set? Can you draw an open interval inside null set? Yes, yes, that's right. Empty set. Okay. If you take A to be closed interval 2, 3, or let me not take closed interval 2, 3. Let me take close 2, open 3. What is the interior of this set? Yes, Durva, right. The interior is what? Open 2, 3. Okay. So these are some of the very important things that one should really know while studying topology. Apparently, my time is about to end. I will just show you one or two things for students who are in graduation. Okay, I can certainly benefit some graduation students. Okay, I will quickly share my screen in a minute. Okay. For post-graduation students, not much, but a little bit of what I can help you. So I will just write my small website I have created for my students. If you have time, you can just Google sites dot Google. I've not shared the screen, right? I'm sorry. I'll just share the screen. Okay. Can you see the screen? Someone can just type a yes.
Yes, sir.
Okay. Thank you. Okay. So this is a small site that I've created for my students. Okay. Here in this site, I have done what? I have done courses. You can see in the courses for graduation students, FY, SY, TY, various subjects are there. And for them and for even for master students have done a little bit work. You can click this objective tests. Okay, when you click the objective tests, group theory, partial differential equations, ring theory, real analysis, complex analysis, whatever tests I have prepared for my students, I have given the links of those tests. Okay, and these tests you can go and try. Where if you say that my group theory subject is well done, you can go and try these small tests. They just contain 4 to 5 questions. Every test contains only 4 to 5 questions. Okay, and some of the tests are prepared by my students. Like for ring theory tests, my students prepared some tests, then they sent it to me. I checked whether the questions are correct, answers are correct, and those tests are also. So all tests are open for you people. Okay, you can go and try. You will immediately get to know the answers. You will get to know your score. Okay, and in this all the courses, suppose I'm in third year student and I need some help in ring theory. Okay, there are many videos, small videos of 5 minutes, which are based on simple topics. Suppose I want to learn what is Boolean ring, ideals in a ring. You can go and have a look at this. Some videos are kept private and some videos are open. So whatever you think, suppose if you say that, sir, I need some help in linear algebra course. Okay, and I want to watch this particular video of yours. You can just go to my home. Here my contact number is there. Here my email is there. Try to contact me in any possible way. Just mention, sir, I need this video. Can you just open the video for some time? I will watch. Okay. So I hope this much will be beneficial for you people. This is at the most I can do from Pune for students who are sitting way far away in Nanded. I think I should now stop here. Okay. Any questions? Any suggestions, opinions, whatever? Otherwise, Chavan sir will thank me quickly. Yes.
Hello.
No questions from any participant? Any questions from participants or any queries or any doubts? You can ask.
Don't ask a very lengthy doubt.
Yeah.
Because students don't like ask doubts
I
at the
think
ending of the session.
no doubt or queries because you have presented graphically all these. Very nice.
Thank you, sir.
Yeah. I think there is no question. So we will conclude here. I am very thankful to Dr.
Pratul, sir.
Pratul, sir. Sorry. Praful or I cannot read.
Yeah, it's a very different name. It's actually Bengali name, but yes.
Routine name is Praful, so I
Yes.
confused. Yeah, for a very good and nice presentation.
Thank you,
Because if we think of topology, most of students they don't like topology due to the
I know that.
complications. But you have presented very good by graph. They can understood easily. So I am very thankful to of behalf of all the participants.
Yes.
So we will conclude here today's session.
Yeah.
I am thankful to Principal Dr. Punjab Chauhan sir and our friend Dr. Satish Chauhan sir giving me opportunity as a session of the chairman. So we will meet tomorrow for another lecturer. So we will conclude here. Stop here.
Hello, sir.
Yeah.
एक होगे सर आभार मान होगे सर.
Oh, yeah.
हो चल. हॅलो होगे सर. डॉक्टर हॅलो.
बोला सर.
हा
आजच्या लेक्चर सिरीज मधलं 1 वीक नॅशनल लेवल ऑनलाईन लेक्चर्स सिरीज हा 4था दिवस आहे. आझादी का अमृत महोत्सव निमित्ताने आमच्या महाविद्यालयाच्या गणित विभागाच्या वतीनं आयक्यूएफ विभागाच्या वतीनं आणि वायसीएमई यशवंतराव चव्हाण महाराष्ट्र मुक्त विद्यापीठ अभ्यास केंद्राच्या वतीनं हे जे काय 1 वीक नॅशनल लेवल ऑनलाईन लेक्चर सिरीज ऑन मॅथमॅटिक्स अगदी चांगल्या पद्धतीनं चालत आहे. आजचं हे 4थं पुष्प म्हणायला काय व्याख्यान पुष्प असं म्हणता येईल आमच्या मराठीच्या भाषेमध्ये. या 4थ्या लेक्चर सिरीजचे चेअरपर्सन डॉक्टर सूर्यकांत जोगदंड सर, जे विद्यापीठाचे नेते आहेत, प्राध्यापक संघटनेचे नेते आहेत, संत गाडगे महाराज महाविद्यालय लोहा येथील गणित विभाग प्रमुख आहे. यांनी चेअरपर्सन ही भूमिका बजावली, त्याबद्दल मी त्यांचे खूप खूप आभार या ठिकाणी आमच्या गणित विभागाच्या वतीनं आणि महाविद्यालयाच्या वतीने या ठिकाणी मानतो आहे. आणि आजचे जे रिसोर्स पर्सन जे पुण्याहून आपल्याला या ठिकाणी टोपोलॉजी या टॉपिक वर व्याख्यान लेक्चर देण्यासाठी या ठिकाणी उपस्थित झाले. अगदी मनापासून मी त्यांचे आमच्या महाविद्यालयाच्या गणित विभागाच्या वतीनं या सर्व लेक्चर सिरीजचे करते धरते आमचे डॉक्टर सतीश चव्हाण सर यांच्या वतीनं आणि तिन्ही विभाग जे म्हणतो आपण गणित विभाग, वायसीएमई विभाग आणि आयक्यूएफ विभाग या तिन्ही विभागाच्या वतीने मी त्यांचा खूप खूप आभार मानतो आहे. की खरोखरच डॉक्टर प्रफुल्ल गडाटकर सरांनी अगदी हा विषय सर्वसामान्य विद्यार्थ्याला सुद्धा सहजरित्या समजेल. आम्ही जरी गणित विषयाचे नसलो पण 1 तासापासून मी ऐकतो आहे की निश्चितच सरांनी हा विषय अगदी सोप्यात सोपा करून सांगण्याचा प्रयत्न केलेला आहे आणि विद्यार्थ्यांचा रिस्पॉन्स निश्चितच या लेक्चर्सला निश्चितच मोठ्या प्रमाणात या ठिकाणी मिळालेला आहे. कारण सरांनी जे काय एका चॅट बॉक्स मधून विद्यार्थ्याला बोलतं केलं, निश्चितच मी त्यांचे या ठिकाणी एक विद्यार्थ्याला सहभागी घेऊन जे लेक्चर घेतलेलं आहे आणि टोपोलॉजी हा सारखा हा विषय त्यांनी या टॉपिक सारखा विषय त्यांनी अगदी विद्यार्थ्याला सोपा करून सांगितला. त्याचबरोबर अनेक अभ्यासाच्या लिंक असतील, अनेक व्हिडिओ असतील, अनेक त्यांचे जे काय त्यांच्या संदर्भात त्यांनी जे काय केलेलं, जे काय गणित विषयातला अनेक प्रकारचा अभ्यास आहे, तो अभ्यास विद्यार्थ्याला कशा पद्धतीने पाहता येईल ही आमच्या सर्व सहभागी विद्यार्थ्याला या ठिकाणी सांगितलेलं आहे. आणि त्याचबरोबर हे लेक्चर सिरीज पर्यायने सरांचं परतूर सरांचं या ठिकाणी लेक्चर ऐकण्यासाठी निश्चितच अनेक महाविद्यालयातील गणित विषयाचे प्राध्यापक, अनेक महाविद्यालयातील गणित नियमित महाविद्यालयातील अनेक विद्यार्थी आणि YCMU सेंटर ज्या ठिकाणी BSc आणि MSc मॅथ चालतं आहे, अशा सर्व सेंटरचे, महाराष्ट्रातील सर्व सेंटरचे सहभागी सर्व विद्यार्थी या सर्वांचं मी मनपूर्वक या ठिकाणी आमच्या अभ्यास केंद्राच्या वतीनं, महाविद्यालयाच्या गणित विभागाच्या वतीनं आणि IPFच्या वतीने या ठिकाणी आभार मानतो आहे. आणि पुनश्च एकदा सहभागी चेअरपर्सन आणि आजचे रिसोर्स पर्सन यांचं मनपूर्वक मी या ठिकाणी आभार मानतो आहे आणि थांबतो आहे.
Thank you, sir. Thank you.
थँक्यू.
थँक्यू परतूर सर.
Yes, sir. Thank you. Thank you so much.
थँक्यू सर.
खूप छान झालं सर.
हो, छान, छान.
ते मुलांना अगदी छोट्या छोट्या गोष्टी फार लवकर म्हणजे क्लिअर झाल्या त्या ग्राफिकल याच्यामध्ये.
Yes.
खूप छान.
मस्त, एकदम बेस्ट, बढिया.
हा,
Thank you.
चला भेटू.
हो.
गुड नाईट.